Hi, Assalamualaikum warahmatullahi wabarakatuh. Good morning, good evening, and good afternoon, wherever you at, wherever you at. Okay. Today, I'm Muhammad Syabir Omar. My name metric number is AA2302300724. Okay. I'm from Group 5. We'll be present and with my friends lah. Okay. We'll be present about the Baltimore Bridge. Okay. Next. What is about the Baltimore Bridge? Okay, Baltimore Bridge, or we call it Baltimore Truss, is a modified truss developed in the 1870 by Pennsylvania Railroad engineer for railway bridge. The typical truss is extra members. It is unlike similar to the Pennsylvania Truss, but keeps upper and lower the chord parallel. As we have shown in the Baltimore Truss at the top of the left slide. Okay, known for its stress is a simplicity. The Baltimore Truss has additional bracing in the lower section for prevent buckling and controlling deflection. Often is used in the train bridge, and one example is a swing bridge originally built for Canada Southern Rail. Despite the changing of the ownership, now belonging to the Canadian Pacific, now is no longer as the Canadian is Spain's is abandoned. Railway now used for trains a few times a week, maintaining its historic integrity. Okay, next. I will be present about the background of the case study. Okay. The Baltimore Bridge is a project addresses the city need for the better infrastructure due to engaging bridge and a growing population. It is a focus on improving transportation by enhancing connectivity and reducing congestion, aiming to boost economic and development the reshape of the city skyline. Okay, the collaboration is a key element involving the government bodies, engineering firms, and local communities to ensure the successful urban development. The project financing is a mix of public and private resources, demonstrating a thoughtful approach to meet its sustainable financial and needs. It's an innovative design and engineering solution are prioritized for the bridge longevity and structure integrity. The community engagement remains crucial with ongoing effort to align the project with the local aspiration and concept. Okay, next I will give it to my friends. Abuza. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abuza bin Zari, and today I will present about the literature review and theory of our project. So, the Baltimore Trust is actually emerged around 1870s at the golden era of American railway expansion. So, it originally not know where it all start, but engineers have agreed that it start at Ohio and Pennsylvania. So, Baltimore Trust actually are heavily influenced by the Pratt Trust, which features by the web diagonal member. But Baltimore Trust add more diagonal web member and adds more complexity. So, Baltimore Trust add substrate or subtypes that are incorporated in the lower section. So, it will create smaller triangle. As we can see below, this orange line and blue line is the subties that will provide stability and preventing buckling in compression member and controlling deflection under load. So we can also see parallel chord. Unlike the practice, we can see that the upper chords are sloped downward, but the Baltimore Trust features parallel chords in both the top and bottom. So it will create silhouette and further contribute to the structural rigidity. So we will move to the theory. Baltimore Trust has efficient load transfer. Baltimore Trust use diagonal members to transfer load from deck to the deck. So it will efficiently dispersing force throughout the structure. Second, the Baltimore truss enhance stability. The sub-bracing that we discussed earlier, the orange and blue line at the smaller triangle, uh, this is the feature of the Baltimore truss. This smaller triangle provides several benefits. And next, material economy. The design of Baltimore truss minimize the amount of material needed to achieve the required strength. And the last one is adaptability. The Baltimore truss can be adapted to various spans and load capacities by adjusting the dimension of its member and the spacing of panels. And that's all for me.
Hi guys, my name is Muhammad Shazwan bin Shaidan, number metric AA201558. So today I will explain to you guys the calculation about Baltimore Trust. So the question is asked about determine the force in at force IP, CT, and UV. So firstly, if you look at a H point, you know that force HP is equal to 40 kilonewton. And if I draw a triangle and use the tangent formula, uh, I will get a 36.87 degree. So if you look at the diagram, I have point 1, 2, 3, and 5, is it? So each point it has a zero force member, which if look at the point number 1 and 2, first we look at the point number 1, AB and BC. We know that BS is a zero force member because uh, yes, the two members are collinear, one member is on, no external force and no support reactions. So we know there is a zero force member, and it seems like the point number two. Now, if we move to the point number three and four, it's same. It a same, which is a zero force member, which SC and RC it is a zero force member, which it has two members are collinear, one member is on, no external force and no support reactions. Now, uh, now we look at the point number five, which is A, B, A, C, and CE, and the midline is CT, right? So there is a zero force member too, which is have two members are collinear, one member is on, and also no support reaction and no external force. Number two, so we know the FCT is equals to 0 kilonewton. Now we move to the next, which is we want to find the force at IP. Now, if I draw a new line which is n, kita anggapkan n tu sebagai Fy kita, dan Fs kita anggapkan adalah G, P dan juga W tu sebagai paksi X kita. Jadi kita lukis balik, dan pada join P tu kita tahu sum of Fn sama dengan kosong. Jadi kalau kita tengok force untuk IP tu berada di paksi bawah. Dia berada di bawah. Jadi kita tahu kan saya kata N tu kita anggap sebagai paksi Y dia. Jadi uh, FIP dia negatif lah. Jadi negatif FIP sin 2 darab 36.87 degree tolak 40 sin 36.87 degree sama dengan kosong. Jadi force untuk IP kita akan dapat compression. Now, untuk nombor 3 pula, kita perlu mencari moment pada M untuk mendapat external force pada A lah. Okay, jadi AY-nya kita akan mendapat 36.67 kilonewton. Dan bukan tu saja, kita perlu juga mencari pada G. Kerana kalau thrust ni kalau kita lipat, dia akan mendapat bentuk yang sama. Jadi kalau kita cari yang sebelah kiri atau kanan pun dia akan mendapat jawapan yang sama. Jadi kita cari moment pada G, kerana force UV darab 8 tambah 36.67 darab 18 sama dengan kosong. Jadi force untuk UV kita dapat compression negatif 82.50 kilonewton. Jadi kesimpulannya force untuk IP dan juga UV sebenarnya adalah compression, dan juga force untuk CT sama dengan 0 kilonewton sebab dia adalah zero force member. That's all for me. Thank you.
Assalamualaikum. Today I am Rishami Member Sofian, no metric AA 23096 will explain the discussion and conclusion that exists in our project. First of all, for discussion, I will talk about load consideration. Analysis involves understanding the type of load acting on the truss, and load consideration is a basic step in the overall analysis and design process of truss structure. After that, the second important significance of truss analysis. Truss analysis is very important in structural engineering, assessing the stability, strength and performance of framework in building and bridge. Finally, there is material selection. The choice of material is important given the safety factor and the combination of load so that no accident and injuries occur. For the conclusion, I will share some of the information contained in this project. First of all, important joint because the joint connect the truss element and the structure is very important for overall stability. The second is load analysis method. Joint method and section method offer different approach to assessing line strength and support response, and each method come with its own set of observation and limitation. Last but not least, the member strength assessment is to check the strength of the truss member involved, assessing the tension and compression force, and checking the strength of the truss member involved, assessing the tension and compression force. That's all from me. Thank you.